Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to talk about how to find the minimum concentration that is required to selectively precipitate out particular ions. So I'm going to go over a couple of examples. The first example, well, it's basically one example with two situations. So the first situation is we have seawater. And seawater has, in this particular case, a magnesium 2 plus concentration of 0.059 molar and a calcium concentration of 0.011 molar. And we're told that we could selectively precipitate the ions with KOH. So they're asking, what is the minimum OH concentration or hydroxide concentration necessary to trigger out the precipitation of the magnesium ion? So what you want to do first is you got to understand when are you going to precipitate? You're going to precipitate when the Q value, right, your quotient is equal to the KSP. So when your concentrations of your ions are such that when you calculate them right now, as they are right now, that would be Q. And then if Q is equal to KSP, then you're on the cusp of precipitation. So that's when they're going to begin to precipitate. That's going to give you the minimum amount. And so once you set those equal, you just set KSP equal to Q and then solve for the ion that you are interested in. So here, the KSP for this, let's see. So for magnesium hydroxide, which is what we would be forming, the magnesium hydroxide would have a KSP of 2.06. So for magnesium hydroxide, the KSP is equal to 2.06 times 10 to the negative 13 times 10 to the negative 13. So that's your KSP. So for precipitation to occur, at the very least, your Q value should be equal to the KSP. So we can set that equal to Q. And then your Q value, or your Q, is equal to the expression of the same expression as KSP, which in this case is going to be the concentration of your magnesium. So if you write the dissolution equation for magnesium hydroxide, it would be OH2 solid. That's going to break down, it's going to dissolve into Mg2 plus aqueous plus 2 OH minus aqueous. And so then using these, we can get the concentration of Mg multiplied by the concentration of OH minus squared because of the 2 coefficient there. So this is our Q expression. So now all we need to do is plug in what we know about magnesium. So here the concentration of magnesium is 0.059. We got this equal to the KSP. Now all we need to do is solve for hydroxide ion. So if we write this down here, it'd be 2.06 times 10 to the negative 13 is equal to 0.059 times the concentration of OH minus squared. So you just divide both sides by 0.059. Okay? And then you are going to have to square root both sides. And then you get the OH concentration. The minimum OH concentration that you would need would be 1.9 1.9 times 10 to the negative 6 molar. So negative 6 molar. So this is the minimum OH concentration that you would need to get precipitation of your magnesium 2+ ion. All right, so that's if you are starting with this molarity of magnesium. What if you are starting with this concentration of magnesium? What would the minimum be at that point? Well, you would just do the same concentration or do the same calculations before. So, so in this case, KSP is the same. So your equation would then be KSP, or is equal to, we don't have to rewrite everything. So then what we're going to do is, it's going to be 2.06 times 10 to the negative 13. And that's going to be equal to, again, it's going to be equal to these two, but instead of 0.059, we're going to have 0.025. So it's going to be 0.025, 0 after this, no. And then multiplied by OH minus concentration squared. And then again, you would divide both sides by 0.025, 0.025, and then square root each side. And then your OH, your minimum OH concentration would have to be, and so this would be 2.9 times 10 to the negative 6. So your minimum would have to be 2.9 times 10 to the negative 6 molar. So you would have to have, it looks like a little bit more. So you'd have to have a higher concentration, slightly higher concentration of your OH minus, because you've got, it looks like you decrease the amount of your Mg 2+. So that's how you figure out the minimum amount that you need to selectively precipitate out a particular ion. I hope this was helpful. I hope you enjoyed the video. If you like my videos, please like, share, subscribe, hit the notification bell, put a comment in the comment section, and thanks for joining me. I'll see you guys next time.